So now we're going to graph a cosine curve, and we're going to do a similar approach. We're going to look at a table of values. So this will be our x. Our output is going to be cosine x. That's like our y. So we're doing y equals cosine of x. Okay. And we'll start in the first quadrant. We're going to start at 0. And we'll do pi over 6, pi over 4, pi over 3, and pi over 2. That will be the first quadrant. So we're looking at going from here, and we're going around to that part of the circle. Okay, so what's the cosine of this, point right there? What's the cosine of 0? It is 1. Decimal approximation, 1. Okay, cosine of pi over 6, that's the square root of 3 over 2. Again, you can use your unit circle if that's helpful for a reference. The decimal approximation we learned from the other graph was 0.9 on that. Pi over 4 is the square root of 2 over 2. Now remember these exact values that I'm writing, the square root of 3 over 2 and the square root of 2 over 2, those are important. They usually want us to have exact values for our answers. However, we're graphing, so we need a decimal approximation to be able to know where it is on the graph. All right. And then that was 0.7. Pi over 3, the cosine of pi over 3 is 1/2. And that's going to be 0.5. And then the cosine of pi over 2 is going to be 0. Okay, 0. All right. Now, we're going into the second quadrant. So let's say 2 pi over 3. Which would be like a little bit more here. Okay, so maybe right there. And you can see that the cosine's got to be negative, right? So think about your all smart trig class or something like that. Anyway, it's all positive here, and then sine is positive here, but not cosine. So cosine is negative in the second quadrant. So that's going to be negative 1/2. Or negative 0.5. And then you're going to have pi over 4. I'm sorry, 3 pi over 4. And that's going to be the negative square root 2 over 2, which is going to be negative 0.7. And then you're going to have 5 pi over 6, which is going to be negative square root 3 over 2, or approximately negative 0.9. And then that's taking you through those angles there until we get here at pi. Now, what's the cosine of pi? Negative 1. Okay? Now, let's see what that looks like so far. I'm going to mark off on my graph 2 pi. I'm going to eyeball that and cut it in half and make that pi. And then I'll cut it in half again and make that pi over 2. And then I'll cut this one in half, and that'll be 3 pi over 2. Now, those are the quadrantal angles that I've put on my graph paper. It's pretty standard when we graph these to use those, or when we transform them, the appropriate transformations then. Okay, what's my highest output? 1. And my lowest output is negative 1 so far, but we kind of know that's going to happen. Okay, now what about pi over 6? Well, pi over 6 is going to be about 1/3 of the way. Yeah, should be maybe a little bit more. And then pi over 4. Oh, no, I'm doing the wrong thing. That's not right. I went 1/3 of the wrong distance. 1/3 of the way between 0 and pi over 2. Okay, so 1/3 of that's going to be maybe there. That would be pi over 6. And then halfway in between would be pi over 4. And then 2/3 of the way would be pi over 3. And you probably can't read those, but they're these right here off the chart. Okay. And so we have points at 0, 1, right there. And I always remember cosine starts at 1, okay? And then pi over 6 is like 0.9, so it's way up there. Then pi over 4 is 0.7, so a little bit lower. Pi over 3 is halfway, so maybe right there. Maybe right there. And then pi over 2 is at 0, okay? Now we went into the next quadrant. And so we had, I'll just mark them off, we had 2 pi over 3, which we'll say is right there, and that was going to be negative 1/2. I wish it would just make the mark. Okay, there it is. And then we had 3 pi over 4, which is going to be like halfway between pi over 2 and pi, and then that was at negative 0.7. So right there maybe. Kind of hard to see my dots. And then 5 pi over 6 was 2/3 of the way. And then that was at negative 0.9. Right there. And then finally at pi it was negative 1. So there's actually a curve here. I don't know if you can see it very well. It should curve a little bit like that. And then what happens when we get to 3 pi over 2? Well, at 3 pi over 2, we're going to be all the way over to here now. And so the cosine is going to be 0. And it's going to be 0. Decimal approximation for 0. And then when you get all the way back to 2 pi, you've completed the circle then, and you're back to having 1. So an output of 1. Okay. So the curve is going to come up here like that. So that's kind of what it looks like. My 1 looks a little high, but it's kind of this shape. Okay? Like that. All right. Now that's one full period. From here to here is one period for the cosine curves, one trip around the circle, okay? Those lines continue because it's a periodic function. It would continue in that pattern. You may have seen wave patterns like that in a science class or something. It also continues in the other direction. Oops. Like that. Okay, and the pattern would continue. So the domain is all real numbers. The range, my highest point is 1 and my lowest point is negative 1. So the range is from negative 1 to 1. The period is 2 pi. It's one trip around the circle. So to complete that section, that is one period. Now sometimes they'll say graph over 1 period or graph over 2 periods. It just depends on the directions. Symmetry, you might remember that cosine cosine of the opposite of x is equal to cosine x. It is an even function. An even function means it's symmetric about the y-axis. Okay? So if I have my, grid here, and I were to draw a cosine curve, remember it starts at 0, 1, so it goes down like this, kind of like that, and then like that. But if you fold along the y-axis, the points on the left should match up with the points on the right, okay? So it's symmetric about the y-axis. It's an even function. All right, that's the cosine function. You may say, wow, it looks a lot like the sine function. And you're right, it does. It's just shifted, really, is what's happened. But we'll talk about that more in the future. So we want to be familiar with what a sine curve looks like and a cosine curve.